Hello everyone. So what we're going to do now is define a lab project. After we get through all the subjects and on packet tracer physical features, we're going to create a lab and test our skills to in practice lab to my project. So let's begin. We need 6 pieces. So let's do like this: 1, 2, 3, 1, 2, 1, 2, 3. Copy, paste. Here and here. Let's just keep them in order. All right. 6 pieces. All right. 3 switches. 3 switches here. 1, 2, 3. 3 routers. 1, 2, 3. 1 more switch. And 2 servers. All right. Before we give IP addresses to home, let's just write what we want. This is going to be the server form LAN. This is going to be the office LAN. All right. Here is going to be, after we define this, before we set what we want to the networks, let's cable the computers to the switches and all of this. Let's set it in at 1, 2, 1. This is for 2. And this is for 3. Same thing. This 1, 2, and 3. We want to connect this with gig 01, gig 01, and this we want to connect with fast Ethernet 4 to fast Ethernet 1, and fast, we need a crossover cable. Let's delete this cable. We want the crossover fast Ethernet 4 to fast Ethernet 1. This fast Ethernet 4 to 2. Now with the whole regular cable, fast Ethernet 1 to gig 000, gig 001 to gig 000, gig 001 to 000, and gig 001 to gig 01. I need to do this with crossover cable as I forgot. Let's create 01 to 01, crossover from the router to router, and regular cable from switch to router, and regular cable from this to this. What we're going to do now is to give name for the router. So this is our server. This is our middle. This is our Argon. This is going to be a VTP SRV. This is going to be SW100, SW200, SW300. Now we're going to give the computer this is going to be PC3/PC3. This is going to be on the VLAN 200. This PC1, PC2, PC1, PC2, and this is going to be PC3. All right, so we get names for all the, this is going to be a DNS. and this is going to be a web. All right. After we give everything in, let's define which networks we want to use in the future here. So it's going to be 103, 102.40.0/16, and this is going to be 172.41.00/16. This is going to be left. Left is going to be 140.01, and right is going to be 172.40.0. This is going to be 172.41.01. This is going to be the left. And the right is going to be 172.41.02. All right, so we have all now. We defined almost all. Let's just define the server. Just a second. We want to define the server. We're going to do this. Just a second. All right, the DNS, we're going to give it IP, static IP 192.168.0.1. The default gateway is going to be 192.168.0.254. The DNS is going to be this. All right, so let's go to the web. In the web, we're going to do 192.168.0.2. We forget 192.168.0.254, and the DNS is going to be 192.0.1. All right, so we define this. Let's write here 192.168. 192.168.0.0.24, 192.168.0.254. Right, let's see that we make 0. Yes, so now we're going to do like this. All right, so let's start. After we create the VLANs, we give IP addresses to. Let's start giving IP addresses to the computers. So let's define that it's going to be VLAN 100, VLAN 100. It's going to be with 10.0.100.0.24, 10.0.100.254, VLAN 200 going to be 10.0.200.0.24, 10.0.200.254. Different gateway. Let's put it in, and this I will put in. This I will, for not forgetting, this is going to be VLAN 200, and this is going to be VLAN 100. All right. So we define this. Let's give them the IP addresses: 10.101, 255, 255, 255, 10.100, 254, right? 10.100.10.0.100.2, 10.100.254. All right, let's see that I don't make any mistake. All right, this is also 100. 3, 255, 254. All right, let's give the VLAN 200, 10, 201, 255, 255, 250, 10, 0, 254, 10, 0, 202, 10, 0, 204. 0. And the last one, 10, 0, 0, 203, 255, 255, 10, 0, 200, 254. And that's it. We give all the computer IP address, we give the server's IP addresses. And now let's just configure the switches. So what we're going to do now is get inside the switch, CLI, and we're going to do en config, and we give him a name, host name, SW100. This is going to be the thing that we're going to do with all the switches. Config, host name, SW200. En config, host name, we're going to give him the VTP SRV. All right, the router. Yeah, config, host name, Argon, right? En config, host name, middle, no, en config, host name, service, server, and the last one, en config, host name, host name, SW300. All right. After we define a host name to all the switches and routers, I already create a notepad with the basic configuration that we're going to do to all the switches and the routers. So you can write each one of them, or you can just do it like this and just take all of these commands, copy that, go to the switch and just paste. And after we paste, all the commands are that you can see is already in. So this is the configuration that we need to do to the switches and the routers, the basic configuration. So why not do this to whole and not going, oh, username, Argon, and write everything. All right, so we defined SW100. Let's go to SW200, paste, VTP, paste, paste, our middle paste, paste. Let's say that I saved almost 15 to 20 minutes that I doing this thing within 20 seconds. So that's cool. Do it like this. You don't need to work hard, just work smart. All right, so we have do all the basic configuration. Let's do reload all the switches and the routers to see that we have all the configure right. All right, reload. Do WR save the changes. Do reload. It's reloading. Let's reload all. Do WR. Do reload. Do WR. Do reload. The routers are not starting, so we do this later. Do WR. Reload. Do reload. Do it also for this. Do WR. Reload. Do WR. Do reload. Do WR. Do. Let's just go forward, and then We set everything, let's see that it's created. Username Argon, password 1234, enable mode, password. So we can see that all is set. The banner, the username and password, enable secret, everything. Now, what we're going to do after the basic configuration, let's see. Now we're going to create VLANs. So we need to create VLAN 100 and VLAN 200. Let's do this. And we create VLAN 100, VLAN 200, and a native VLAN, the VLAN 555. Okay, so let's go to the switch, config C, VLAN 100, name VLAN 100, VLAN 200, name VLAN 200, VLAN 555, name VLAN 555. Let's do the same thing for this switch also. Argon 1234, enable config C, EN 1234, config C, VLAN 100, name VLAN 100, VLAN 200, name VLAN 200, VLAN 555, name VLAN 555. All right, we can do show VLAN and see that it's great. We show VLAN, absolutely. Let's go to the VTP and create it also. Argon 1234, EN 1234, config C, VLAN 100, name VLAN 100, VLAN 200, name VLAN 200, VLAN 555, name VLAN 555. All right, exit. Now, after that, we're going to create what we're going to do. Let's see. I want to see what we're going to do. We're going to create after we create VLANs, we want to take the interfaces, these three interfaces, and these two computers we want in VLAN 100, and this computer is VLAN 200. So this interface needs to be to VLAN 200. That is going to have a connection between them. Also for VLAN 100. So let's do it. Exit. Let's go to the interface FA range. Interface range. Interface range. FA 0, 1 to 2. We're going to do two things. We're going to create this. No, we're going to do things by things. Okay, so now we want to switch for access VLAN 100. All right, interface FA3, switch port access VLAN 200. So now if we go to do show VLAN, we can see that interface F01 and 02 is on VLAN 100 and 200 FA3. Let's do the same thing in exit interface range FA1 to 2, switch port access VLAN 200 and interface FA3, switch port access VLAN 100. Hallelujah. So now do show VLAN, we can see the same thing. All right. After we get inside all the interface to the switch, what we're going to do now is to create a switch port security. With this thing, we get these three interfaces to be the only the MAC address of this computer will be sticky to the interface. So if I connect another PC, it cannot be connected. You will see. I will explain it. So now we get inside. Exit and we take a range of the three interfaces, 1 to 2. Right? We are inside. Let's do this thing. Switchboard for security, switchboard mode access, switchboard no negotiate, switchboard for security make sticky, switchboard for security max 1, switchboard for security violation shut down. That's all. Let's do the same thing here. Exit interface range FA0 to 3, switchboard for security, switchboard mode access, switchboard for security max sticky, switchboard for security violation shut down, switchboard for security max 1, switchboard no negotiate. All right. So what we're doing now, we make sure that this MAC address of the computer will save in the switch. And if I change computers to another computer with another MAC address, there is no connection between them. I can show you if I doing something like this. Let's create this laptop, attacker, and let's just send ICMP from here to here. It will be when okay, let's do the trunk and then it will work. Let's do the VTP and I show you that it's sticky here. All right. So now what you're going to do is to create this interface and this interface at trunk. Let's do. So interface give 01, switchboard for security, switchboard mode trunk, switchboard trunk allowed VLAN 100 200, switchboard trunk native VLAN 555, switchboard no negotiate. That's all. Let's go to this interface V01, switchboard for security, switchboard mode trunk, switchboard trunk allowed VLAN 100 200, switchboard native trunk native VLAN 555, switchboard no negotiate. All right, that's it. Trunk allowed, trunk yes. Okay, so we do this for this and this. Or we need to do this also for this interface. F8 4, switchboard for security, switchboard mode trunk, switchboard trunk allowed VLAN 100 and 200, switchboard trunk native VLAN 555, switchboard no negotiate. All right, let's do the same thing to this interface F8 4, switchboard for security, switchboard mode trunk, switchboard trunk allowed VLAN 100 and 200, switchboard trunk native VLAN 555, switchboard no negotiate. All right, so we create this also. Let's do the same thing to FA interface, FA range, FA 01 to 2, 1 and 2, yes. Switchboard for security, switchboard mode trunk, switchboard trunk allowed VLAN 100 and 200, switchboard trunk native VLAN 555, switchboard no negotiate. All right. So what we do in this thing, we create this interface, this interface, this interface, this interface, this interface, and this interface to a trunk mode that we can move more than one interface or one VLAN from the interfaces, and not like here that is sticky, and you can also create one. Now let's create this to a VTP server. VTP server can in the future, if we want to add a VLAN to the network, we don't need to go in this switch and this switch, and if we add another switch and another switch, we just create it in, and we make it a VTP server, and these two switches we create to a VTP client, and then when I create a VLAN here, it's already synchronized with this switch and this switch. Let me show what we're going to do now. It's VTP mode server, VTP domain Argon just local, VTP password 1234, and VTP version 2. Right, that's what we need to do. Here we're going to create VTP mode client, right, VTP domain Argon just local, VTP password 1234. All right, let's do the same thing here. VTP mode client, VTP domain Argon just local, VTP password 1234. All right, let's see. Now we're going to this switch and we create VLAN carta de pita. We're going to do 1, 2, 3, 4, 1, 2, 3, and name carta de pita. All right, let's see in this if it's created here. Do show VLAN, and as we can see, we have carta de pita VLAN, and we can write no VLAN 1, 2, 3, and we can go back to here, write the same thing, and we see that it disappeared. All right, so this is the VTP server, and that's all. Now, what we're going to do to see that we have a connection between these two computers, and now the computer is sticky. All right, and we also have a connection between this and this computer, as you can see, and between this and this, and between this and this. All right. So now, if I take the attack here, now it's interface the FA. Let's do its interface FA2. All right. So let's just disconnect it. Let's just disconnect this interface and take the interface here. Let's give him a high IP also. 2. Let's give him, for example, this is a V100, 10.0.100, 5, subnet mask, 255.255.255.0. We forget gateway 10.0.154. And as we can see, in a few moments, that if we try to connect with this laptop to this, we have a connection. All right. Mode access. Let's see. Argon 124, EM 4, do show R. Let's see what we create in the switchboard mode access, which and we didn't create it. We created sticky. So why it didn't already? All right, let's take it for you. Let's do like this. All right, with connection. Let's do interface range. Interface range. FA0, 5, 2, 4, range. 0, 4, shut, Right. Let's try to connect him to another switch. With this section, we just let him understand that if I connect, if the attacker connects himself to interface 5, so he cannot do anything because I shut down the connection. I will come back to this later with the sticky. All right. So now we can see that the attacker cannot do anything. Let's do the same thing here. Here, interface range FA0 5 to 24. Shut. All right. All right. After we do that, we're going to create a sub interfaces from this gig 0, 0, 0, 0. We're going to create a two sub interfaces to this VLAN. So let's start. We get inside the CLI on 16, interface gig 0, 0, 0, point 10. This create a sub interface. Let's do encapsulation dot 1Q, and it's going to be 10 for VLAN 10. IP address 192.168. No. 10, 0, 100, 254, 255, 255, 255, 0, and no shut. Now interface gig 00020. No, no, no. No. Interface. No. Gig 0. All right. So we delete it because it's not 10, it's 100. So let's be accurate. Gig 0, 100. Encapsulation dot 1Q 100. IP address 100, 254, 255, no shut, shut, no shut, shut, no shut. Down, shut, no shut. Change state to down. Why change state to down? Let's see. No show out. Interfaces. All right, we have interface lead, encapsulation here. That's the don't show how. Let's see. Show how. No. Show how. Show how. We see that we delete the interface. Yes, we delete. Let's on CC. Shut. IP address 1. No shut. Shut. No shut. Write down. For God's sake. All right, I understand. Let's do exit. And this is 0. Shut. No shut. Yes, let's get it up. Interface. Gig 0. Shut. No shut. Up. Now it's up. I understand the problem. All right. So we create for this. Let's create for 200 encapsulation dot 1Q 200 IP address 1. 0, and no shut, exit. Now I create the sub interfaces. As we can see, we have two sub interfaces, 0.100, 0.200. Let's see that we have a connection between all the computers now. All right, in progress, fail, y is fail. Okay, we do this for the DHCP. Let's see that we can take. All right, just a second, let me see. And let's create a DHCP pool, and we can get it later. IP DHCP pool Argon 100. This is for VLAN 100. And network 100 from 0 to 0. This for router 10 0 100 254 DNS. We want to use this DNS because in the future we're going to use it, so it's going to be 192.8.0.1. Domain name argon.local. So we define this. Let's do exit, and now we want to create another DHCP pool Argon 200 network 200 0 255 255 default router 10 0 200 254 DNS 121.0.1 domain Argon. Let's see that the DHCP is working. Let's go to PC, to network VLAN 100. I will use the DHCP. Okay, we have a problem. Houston, we have a problem. Let's see what is the problem. We're getting a pipa, so it means that we don't have the right thing. All right. Let me see. Do show out. Okay, we have pool 100 and pool 200. 10, 200, 10, 10, 10, 10. All right, this is okay. Interface 100, that's 100. This is the distributor. There is no problem with it. So the problem is in the switches, I guess. Let me see. Oh, in the computer. Let's try it. Now we get a pipa. Let's try it. Maybe it's something wrong. Yes, it's a pipa. Let's see why. Let's do a simulation. And let's try to get an DHCP. All right, let's see where it's stuck. Yep. All right. So it's stuck in the VTP. Yes. Oh, I understand what is the problem, what we didn't do. Okay, let's do this thing again. Man, I just want to do this. 150 and int give 01. And we didn't create it as a trunk. Switchboard for security. Switchboard mode trunk. Switchboard trunk allow VLAN under 200. Switchboard trunk native VLAN 555, switchboard, switchboard, no negotiate. Every, let's do it now. 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 All right, we get it. We get. Yes, we get. Yes, we get. Yes, we get. Yes, and we can see that we have a connection between all the computers now. What we want to check later before. So now we can see that we have a connection, connection. Okay, so we finished with the DHCP. After we do port security and DHCP and the sub interfaces, and BTP server, and access mode on the port security mode access trunk. And we see that if we shut down the interfaces, there is no computer that can get inside the LAN. With the sticky, we create this MAC address on the list, on the table list, and only this MAC address can get inside these interfaces. All right. So after we create the DHCP and for security, what we want to do now? What do we want to do now? Let me see. We'll give them static key. Let's create on the DNS. Services DNS. Let's create a name. We're going to create a www.argon.com. The address is going to be 192.168.0.2. It's going to be the web. So let's do add, and we add the thing to the list. All right. In the website, you can see that the services is HTTP on or HTTPS. What we're going to do now? Let me see what we're going to do now. What we're going to do now is this. Now we're going to give this interface an IP, 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 and this is going to be the router on a stick. No, this is not going to be the router on a stick. It's just the beginning of static route that we want to create. So let's get inside this router Argon 124.50 interface gig 0001. IP address 172.41.0.2 255.255.0.0. Voila. No shut. Shut. No shut. And the interface is up. Now let's go to this interface, to this router. Argon 124.50. Let's go to interface gig 000. IP address 172.41.0.1 255.255.0.0. Shut, no shut. All right, that's it. Let's go to another interface. Interface gig 001 and IP address 172.40.0.2 255.255.0.0. Shut, no shut. All right. Let's go to this router. 4.50 interface gig 0.0.0.0.1 IP address 172.40.0.2 255.255.0.0. Shut, no shut. No, I made a mistake. Let us give 000. No IP address. IP address 122.40.01.255.255.00. Let's do this. 41. 41. All right, this is a mistake. This is a mistake. The 0, 0. No, IP address. IP address. 32, 41. Sure, sure, sure. Interface name 0, 0, 1. No, IP address. 40, 0, 2, 0. Shut. No, shut. All right. This will be 41. Not IP address. IP address. No. No. One, two. What is the fucking problem? Oh, all right. All right. All right. IP 01, 255, 255, 00. No. Do with the internet 001. Right. This need to be. Oh, let's define this for a second. IP address 192.168.0.254. Shut. No shut. Let's go to 000. IP address 1.01. All right. All right. No shut. Shut. All right. Now interface with 001. IP address 172. 4. Shut. No shut. Interface with 001. IP address 172. 41. 01. 255. No shut. No shut. All right, and the last one, which is with 001 IPL, yes, 4102, shut, no shut. Yo. So after we define all the interfaces, now let's see that we have a connection between this and this. This and this. All right. So we have a connection between the routers. Now, what we want to do is to do IP route and let this router know this network and this network and this network, and let this router know this network and this network, and let this router know this network and this network. Let's begin. All right. So what we're going to do now, exit, 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 exit. Let's do IP route. Which computer, which network we want to know. We want to know IP route 172.41.0.0. We want to know this network. From where? From this interface. The sum mask of course of the network. We want to know this from this interface. So we want to know it from 47, 40. From 140.02. Absolutely amazing. Now we want to know this network. From where? From this. So here we have 10, 0, 100, 0, 255, 255, 255, 0, and we have also 200. All right, so we have 3 routes. Let's go to the R middle. Here we need to know this and this. So IP route 197.168.0.0, 255.255.255.0. From where? From here. So it's 172.40.0.1. And for this, we need to know this. We want to know this from this interface. So it's IP route. We want to know 10, 100, 0, 255, 255, 255, 0, from 172.41.0.2. We want to know also 200, and that's it. Let's go to the last router, and we want to know this network and this. So IP route 172.40.0.0, 255.255.0.0 from this interface. So we want to be 117.41.0.1. And we want to know this also. So let's do the same thing and it's from the same place. So it's going to be 128.0.0. 255. All right, so we have 2 IP routes. So that's it. Let's make forward for a couple of seconds. And let's say that if we have a connection between this and the server. Oh, we have a connection. We have a connection between 2 different LAN. From the office LAN to the server farm LAN. So now we can have the services of the web off or the DNS. So after we do this, let's see for a second the do show IP route that you will understand what we do. IP route. You can see that we have a static that we created, also static, and we can go to this and do show IP route, and we can see that we create this static where we want to which network we want to see this from where, from this interface. All right, so what we're going to do now after we do the static IP route, we're going to create an ACL. Create the ACL, right? Let me see. Let's see if we create the ACL. Before show that. Oh, we didn't create access list. Okay, so let's do ACL. what we're going to do with the ACL, we're going to let me see, just a second. All right. What we're going to do now, it's a ACL access control list. We're going to define that these two networks cannot talk with each other, and they can talk with anybody else. So it's the server for in this situation, and only VLAN 200 can control the switches and the switches. All right, so let's create it. We're going to switch 100. Let's do the spin. Argon 122, Argon 124, VN 124, 150. All right, so let's do a access list 1 pyramid host 10 0 200 1 the same thing with 2 the same thing with 3 and access list deny and deny enemy. And we do show access, do show because we are in enable mode. Do show. We can see that we have the rule. Let's go to the let's do this. All right. Do the same thing again. 115. This 1 pyramid of pyramid of 10 0 201 2 3 deny this one deny. All right, let's do this thing also in the VTP. Argon 124 config pn 124 config access list 1 meet host 10 0 201 2 2 list deny and line VTY0 access group 1 in. That's the different thing. Line VTY0 access group 1 in. 115 line VTY0 access group 1 in. So now everything is inside. Let's see that we have a connection only from VLAN 200. All right, let's do SSH. Argon 1. We need to set the interfaces. Exit interface VLAN 200. IP address 191.10 0 200 101 255 0. No chat. Right. Exit VLAN 200. IP address 1 2 255 0. No chat. VLAN 200. Alright. IP address 1 2 0. No chat. Alright, let's see that we have a connection. SSH connection. SSH Argon 201. Alright, Houston, we have a problem. Oh, it's no, it's VLAN. Let's see for me. 200, right? Bit 2, with 3, with, let's see if we have the router. 4, 4, the router. Boom. 104, right here, 200. All right, let's define VLAN 100 to see that we cannot connect to the interface. VLAN 100, right it up, IP. Let's do 100, 101, 255, no shot. Let's see if we can connect to the switch. SSH, Argon, and now we can see that if we try to set the password, it's not let us in, and we set the right password. So with the ACL, we give the permission only to VLAN 200. Computers that's inside VLAN 100 cannot do SSH connection to the switch. All right, so the ACL is well. Let's go now to the router and create and deny internet protocol between the LANs. That, as you can see now, we have a connection between the computers in the different LANs. Let's do things that deny this. All right, so what we're going to do is IP access list extended VLAN 100. We're going to do deny IP from VLAN 100 to VLAN 200. And we're going to permit any IP, any. After that, we're going to the interface gig 000 and we're going to do IP access group, IP access group VLAN 100 in. All right, let's do the same thing with the VLAN 2 access IP access list extended VLAN 200. Deny IP from VLAN 200 to VLAN 100. And we're going to permit any IP, any. All right, let's go to the interface 200. IP access group VLAN 200 in. All right, let's see that if we have a connection between the VLANs now. And as you can see, it failed. We cannot communicate between the VLANs. But if I communicate with VLAN 200 to VLAN 200, it's perfectly clear. And for the outside, successful. All right, so this is the ACL. Let's see now that we have an option to get inside the web for the URL. And this we can see when we go to IP configuration, we have the DNS. Now let's see if Argon local www.argon.com. No, Argon.com. Argon. www.argon.com. Why we cannot get inside. Let's go to the DNS, Argon.com, 192.168.0.2. Let me understand what is the problem. Go inside this. Let's try another. Let's try something else. DNS name www.soso.co.il. Oh, DNS services. All right. Now it's going to work. All right. It was my mistake. And as you can see, we have an internet connection. We have a web, and the DNS is translate this to the IP, to the web IP. Let's see that we have also from VLAN 200. Yes, we have. All right. So now I want to do a quick brief about what we do in this project. All right. So we create a new lab inside Packet Tracer, and as you can see, this is the lab. We configure basic commands in the switches and the routers. We defined the VLANs, and router configuration plus DHCP services. We see that every computer gets an IP from the DHCP server that's inside the router. And we create a VLAN, VLAN 100 and VLAN 200. And we enable port security on the interfaces, the endpoint interfaces, the interfaces between the switches, the interfaces between the switch to the router, and we enable the port security. We create a VTP server that if we want to create a VLAN, we just need to add in the VTP server and not go to set all the switches and configure the new VLAN. This synchronizes with the VTP server and make our life easier. And we do a router on a stick. What we do in this, we create a sub interfaces that we have only one interface that connects to the switch. So we create two sub interfaces, gig 000.100 and gig 000.200. We give them a different default gateways, and that can be the default gateway to network 100 and to network 200. We create a static route. We let this LAN to communicate with this LAN. We let the routers know about the other LANs, and we set a network and the IP in for the interfaces. And we create the ACL access control list with rules that VLAN 100 cannot speak with VLAN 200, but they can speak with the other LANs. We let only VLAN 200 to control the switches. And I show you that if we try to do this with VLAN 100, it's denied. All right, so I hope, guys, that you are enjoying from my project. This was for my college project. I just created videos to support my project that I made in Word and pictures. So this tutorials will support my project. Thank you guys for watching. In the next video, I'm going to sum up and do a conclusion to the project. Thank you guys for watching. Hope this tutorial was helpful for you. And I see you in the next project.